This video is going to talk about two things, your zero exponents and your negative exponents. I'm just going to go through each example and kind of explain what's going on and address the two properties here. So for this first example, you have 3, and we want to notice that this is 3 times y to the 0 power. So there's your zero exponent. What we want to notice is that the zero exponent is only with the y. It's not with the 3 as well. And so our property tells us that anything raised to the 0 power is going to equal 1 every single time. It doesn't matter what this base is right here. If it's a variable or a number, if your exponent is 0, it will equal 1. So knowing that y to the 0 power equals a 1, I'm going to bring down the 3, and I know it's multiplication in between, so 3 times 1, we get 3 for our answer on that one. Alright, this next example to the right uses both the zero exponent and negative exponent properties. So first, just to go over that zero exponent again, here's m raised to the 0 power. Anything raised to the 0 power will equal 1, so I know that that's going to become a 1. And then here we have n to the negative 3rd power. So what we've been talking about in class is when you have a negative exponent, the exponent with its base has to move. Because right now it's in the top of a fraction, you can think about this as being over 1. This n to the negative 3 has to come down here. And it's that movement that makes your exponent positive. When it comes down here, the base is still the same, so the n did not change, and instead of a negative 3, it's going to be a positive 3. As far as what's left over in the numerator, while your n to the negative 3 has moved, and remember we still had that m to the 0 power, but we know that that equals a 1, so we have a 1 up top. So we have 1 over n to the 3rd power. Alright, next example, 2 over 5m to the negative 4. When we see this example, really the only thing that we think that we need to do something with is this negative exponent. So what we have to just make sure we have straight is the negative exponent with just the m, or both the m and the 5? And because there's no set of parentheses, this negative exponent is only with the 5. That is with the m. That is the only thing that has to move, and because it's in the denominator, it's going to move up top. So when we rewrite this, we want to say, okay, the 2 and the 5 did not change at all. Those did not move. So you still have a 2 up in your numerator, but that m to the negative 4, when that moves up top, it becomes, you keep the same base of m, and now it's a positive 4. Over, and then what do we have left in the denominator? Well, our m to the negative 4 moved, so all we have left is that 5. The 5 did not go anywhere. So we have 2m to the 4th over 5. Alright, our next example, we see that we have 2 negative exponents. So anytime you have a negative exponent, it has to move. So this m to the negative 3 is going to come down to the bottom. So when we rewrite this, your base stays the same, so it's going to stay as an m, and instead of the negative 3rd power, it's going to be a positive 3. But then we may notice, well, hey, we have another negative exponent. This x to the negative 4, that has to move, and that movement's going to make your exponent positive. When that moves to the top, your base stays the same, so it's still an x, but instead of a negative 4, it's a positive 4 power. And then that's all that we can do on that example. Alright, bottom row, we have 1 over x to the negative 2. There's that negative exponent we want to make sure we're noticing. So negative 2 goes with the x, so the exponent with its base is going to move up top because it's negative. When it moves up top, it becomes a positive x, or x to the positive 2 power. And then because everything from the bottom moved up, you could say that it's over 1, or you could just say x squared. Either answer would be fine. Alright, last one. In this example, kind of similar to one that we did in the second row, the thing that we have to work on and simplify here is this negative exponent. and that negative 2 is only with the x, it's not with the 6. And that's the only thing that has to move up to the top. So the 5 stays because it did not have a negative exponent, but now the x is with it, and it has a positive 2 exponent, over that 6 down there. This 6 did not have a negative exponent, so it stays down there as 6. So a few examples to talk about your 0 and negative exponents. Just to recap, anytime you have a 0 exponent, it always will equal 1. And then your negative exponents, the negative exponent with the base will move. If it's in the top, it'll move down to the bottom. If it's in the bottom, it'll move up to the top.